All right, so this video I want to address average atomic mass and what does that entail? What does that mean? All right, so here's just a picture of the periodic table. And so hopefully this looks familiar to you as for what do some of these things mean and what they stand for. And so let's just kind of highlight a couple of things here. So like, for example, we have oxygen, okay? So we know that this is your atomic number, all right? And we know that the atomic number simply represents the number of protons, okay? We know that this is the element symbol, that's the name. Now, one thing we haven't really talked about so far in class is this number here. Now, this number here is what we call the average atomic mass. Now, what does that mean? Well, the average atomic mass is basically the average of the masses of all the isotopes multiplied by each and in relative abundance. Okay? Now, each atom has a particular mass number, and we know that when we talked about isotopes is just basically different flavors of the same atom. All right, so for example, we know that oxygen, for the most part, has 3 stable isotopes. All right, so we have oxygen 16, oxygen 17, and oxygen 18. So these are the 3 that's particularly found in nature. But each of these isotopes, exist in different abundance. All right, so what do I mean by that? All right, well, so far we know on this planet, and it's been experimentally figured out, so I'm not throwing out these numbers. I'm not making up these numbers, all right? So all the oxygens that we found on planet Earth, about 99.76% of it is oxygen 16, okay? About 0.04% is oxygen 17, and about 0.20% is oxygen 18. Okay, and so since each of these isotopes have its different amount of abundance within the planet Earth, all right, the average atomic mass is just basically the sum or the average of all the masses of all the isotopes. Okay, and so how do they figure this out? So what they do basically, and it's simple as this, to figure out the average atomic mass, what you will do is you will add up each of the masses, okay? So you'll figure out the mass of each of these isotopes, all right? You will add them up, but you will also have to make sure you multiply by each of the abundances of the mass. So how does that look like? So we know for oxygen 16, the mass of this is 15.9949 AMU. AMU simply means atomic mass unit. It's like the grams at the atomic level. Okay, so it's just really, really, really small measurement of mass. Okay, so we know oxygen 16, this is the mass. So for oxygen 17, the mass is 16.9991 AMU, and then for oxygen 18 it is 17.9991 AMU. So these are the masses for each of the isotope. Now I want to be able to calculate the average atomic mass of oxygen. So what I'll do is, so I will take 15. So I'm going to take my first isotope. All right, so my first isotope is this oxygen 16 here. I'm going to take the mass, 15.99949, and I'm going to multiply it by the decimal version of the percent abundance. So the percent abundance of oxygen is 99.76%. So I'm going to multiply it by the fraction or the decimal version of this number. And so we know to change this back to a decimal, you move the decimal 2 times to the left. All right, so 0.9976. All right, close the parentheses. Then I'm going to add it up with the next isotope. So the next isotope is oxygen 17. We know that the mass is 16.991 AMU. All right, and I'm going to multiply by its percent abundance, or its decimal abundance here. So remember, I got to move the decimal twice to the left. So in this case, it's 0.0004. And add up with the last isotope, which is oxygen 18. And so in this case, I'm going to kind of slide this over. You have the mass is 17.9991 AMU. And I'm going to multiply it by here its decimal abundance. In this case is 0.002. Okay. So this is exactly what I'm going to kind of plug into the calculator. So if you look at, so I'm just going to kind of highlight it again. So here we have oxygen. So I'm going to show you oxygen 16. All right. And so here is the mass. Here is its percent abundance. So I take the mass, multiply by the fractional abundance. So you're just moving the decimal twice to the left. All right. So that's for oxygen 16. Then I have oxygen 17, okay? Here is its mass. Here is its percent abundance. So oxygen 17, again, here is the same mass multiplied by its fractional abundance, okay? Or decimal abundance. And then we have oxygen 18. Here is its mass. Here is its percent abundance. And then so I have the mass here multiplying by its decimal abundance. Once again, it's oxygen 18. And all you have to do is just plug this in the calculator just like I wrote it down. So when you plug in like this, using the parentheses as well, what you will find is that that oxygen, let me fix this, okay? Oxygen has the average atomic mass of 15.999. Okay, now this number, you can find it on the periodic table as well. So it's there for you. So it's kind of like a way to kind of double check yourself, just making sure that you're doing the math properly. So what does this number mean? Okay, as I said, it's the average of all the isotopes, all right? The sum of all the isotopes multiplied by each of its abundance, all right, decimal abundance. All right, but now when you look at this number, you could actually kind of figure out which isotope is the most abundant, all right? So kind of think about it. So this is 15.999. All right, we have an isotope that's 15.99 here, an isotope that's 16.99 here, and an isotope that's 17.99. So because the average atomic mass is 15.99, we could write, if we didn't have these numbers, your percent abundance or the abundance numbers of your isotopes, you could kind of figure out, okay, due to the fact that the average atomic mass in this case is 15.999, then that means, I guess I should highlight this in red, that isotope oxygen 16, all right, is actually the most abundant of all the three isotopes. So you could kind of see that just by looking at the average atomic mass, okay? All right, so let's go through another example, okay? So we're given the isotopes of neon. All right, so we have, I actually want to do this in white. All right, so we have neon 20, neon 21, and neon 22, okay? And we're given the masses of each of them. So the mass of neon 20 is 19.9924 AMU, okay? The mass for neon 21 is 20.9924 AMU, and the mass of neon 22 is 21.9913 AMU, okay? And then you also are given the percent abundance for each of them. So for neon 20, it's 90.48%. For neon 22 is 0.27%, and for neon 22 is 9.25%. Okay, so just by looking at the percentages, you should be able to kind of quickly figure out your average atomic mass, where that number should kind of lie. And so simply because this is the highest percentage and awfully high, all right, you expect your average atomic mass to be much closer to this number here versus these numbers. Okay, but let's go ahead and figure it out. All right, so we have, so for neon 20, all right, we will take its mass, 19.9924, multiplied by the decimal of the abundance, so it's 0.9048. All right, for neon 21, we have the mass is 20.9924 multiplied by its percent abundance, or the decimal abundance, so 0.0027, plus neon 22, which has the mass of 21.9913 multiplied by its decimal abundance, so here is 0.0925. Okay, so let's just make sure that we have everything here. So we have neon 20, here is your mass for neon 20, here is this mass, here is its average atomic mass, a percent abundance, and then I changed it to the decimal version. Here is neon 21, here is its mass, here's the same mass. All right, here's the percent abundance, I changed it to the decimal. Okay, and then last you have neon 22, here's its mass, same mass, percent abundance, the decimal version, once again neon 22. All right, you plug in the calculator, and what you should get, all right, you should actually get the same number that you find on the periodic table. So just kind of scrolling, showing this to you guys. So let's find neon. So neon is here. The number that you should get in the periodic table from your calculator is 20.180. So once again, your prediction is right. Simply because neon 20, all right, had about a 90% abundance here on the Earth, right? And its mass was, let's just go back, its mass was 19.9924. You see that the actual average atomic mass is closest to neon 20 than versus neon 21 and neon 22. So that's how you basically calculate average atomic masses.